All right, hello everyone. Today it's not about Aeros, it's about PyStorm and Emu68, the open source accelerator for your Amigas. The talk will be split into 4 parts, short introduction, a little bit about the accelerator and Emu68, and then what we are working on, what are the future plans, and so on. Okay, let's start with introduction. What was PyStorm? Claude Schwartz was working in 2020 on connecting Amiga to his Raspberry Pi. His aim was to control Amiga with different device, with Raspberry, without Motorola CPU. He has made an FPGA interface which was matching M68 bus, and he had a software working on Raspberry Pi which was controlling the Amiga. His work was followed by many people on Twitter, for example, and he was showing how he's, for example, playing videos from Raspberry Pi directly on ECS chipset and so on. And at some point he has started to use Musashi CPU emulator, which is relatively slow, but it's pretty precise. The problem with the first PyStorm was it was working on the control of Linux, which means when you have powered on the Amiga, you had to wait a little while until Linux is booting up, and then you had to start the emulator. And yeah, the speed was hardly limited by the emulator. On the other hand, there was me. I was working at that point on Aeros, and Aeros for Raspberry Pi. I was looking for the M68 emulator, and most of them were licensed incompatible with Aeros, so I have decided to have a look if I can write one emulator like that, and yeah, it happens, it seems I can. By the end of the 2090, I have moved to the bare metal, which means the Emu68 was still working without Amiga, but it was working on Raspberry Pi exclusively, which was in principle turning Raspberry Pi into M68 Raspberry Pi. So you could write anything accessing Raspberry Pi hardware directly in Motorola code. It was pretty funny, and by the end of 2020, I have said, yeah, Emu68 is in principle ready. It's so far perfect, I would say, and yeah, I was absolutely and awfully wrong. Yeah, and then at some point, I was lacking the hardware. I mean, I could write some software for Raspberry Pi, but the base of the software available for Amiga is so huge. That's the perfect test bed where you can just run everything you want and see and find out if it's working or not. And yeah, then we have met, I mean, me and Claude. It was pure accident that we are mostly ready by the same time. He had the hardware to control Amiga. I had the software which was running on Raspberry Pi. So I would say the cooperation was unavoidable. Yeah, we just had to do it together. Yeah, so that's the open source accelerator then. Our design goals are: the PyStorm is the FPGA bridge, which is providing translation layer between M68 bus and Raspberry Pi. M68 is running on Raspberry Pi without any other operating system. It's starting directly when you power on the Raspberry Pi. Raspberry Pi hardware, I mean the all hardware which Raspberry Pi has, is exposed in the 32-bit address space of Amiga, which means you can write driver for any kind or any part of Raspberry Pi with that. We have made already few drivers for that, and the other ones are in the work. It's the bare metal code, which means you really have no other operating system running there, and the access to the 40-bit address space of Amiga is triggers MMU exceptions, and the handler is then talking to the Amiga through the Raspberry Pi interface. The Emu68, a little bit about that. It's the just-in-time translator. And some people were asking me, can you switch off the just-in-time translation? Yes, you can. You can just power off the Amiga. I mean, Emu68 is pure just-in-time. There's nothing, no interpreter like that. It's looking at the address which has to be executed. It's searching for the translator block in the cache area of MO68. If it finds one, it executes it, and if not, it translates. There are several optimizations in the MO68. One of the most important ones is elimination of CCR calculations. Also some small parts like program counter, which is not updated after every instruction, just at the end of translated block, or if it's necessary. There is inlining of subroutines, lob unrolling, and instruction merging. Important part which was implemented a few weeks ago is inlining and unrolling is not active when the code is executed from the chip memory, because the chip memory access is slow. And if you inline, which means you have to read much more code before you translate it, it was slowing down MO68 massively. So we have switched off that when the code is executed from the chip memory. So this CCR calculation optimization is very important in case of Amiga, because M68 updates the condition codes basically after every single instruction. And most emulators are just calculating it after every instruction because it's important. On the other hand, as you may see on this small example, not really every instruction would need to update the condition codes, because they are just destroyed by the subsequent instruction. And if they are not used, why calculate them? I mean, it's waste of the time, it's waste of the CPU power. And this is exactly what MO68 is doing. On this example, you may see we have eliminated the CCR calculation from quite a lot of instructions. And on the real code, it happens even more frequently. The code inlining is done if the branch to the subroutine is computable and at the translation time, then the block of the code is inserted to the translated code for the ARM processor. If it's outside of the range, the inlining is not done. And on the other hand, if MO68 cannot calculate the target address during the runtime, during the translation, then it's also not done, because it's then impossible to predict where the code will go. Code inlining is exactly the same. If you have a small subroutine inside of your code, MO68 is using a small return stack where the address of the code executed or before the branch is stored. And if it's possible, it will insert small subroutines into your translated code directly. Lob unrolling is also another feature. If MO68 attempts for us first to align itself on the loops, and if it finds out that there is a loop in the code which is executed for several amount of times or inserted for the several amounts of times, it will stop the translation and force another one which is aligned with the start of the loop, and then the loop is repeated several times, and the jump back to the beginning of the loop is done inside of the code, so it doesn't have to escape to the just-in-time translator anymore. So what hardware do we support at the moment? We have two versions of PyStorm. One is for classic Amigas with Motorola 6000 bus, and there it's working on Amiga 500, 500 plus, 600, 2000 and 1000. And both MO68 and still the old Linux-based Musashi are working there. On Musashi only, there is also support for Atari and classic Macintosh. And we support Raspberry Pi's 02, which is important because classic 0 does not have the 64-bit CPU, so we have to use either 02, P3A, P3B, 3B+, and the one unsupported is Raspberry Pi 4 and CM4. For some people they are working, but we do not officially say they are supported and working. And then we have PyStorm 32 Lite, which is designed for Amiga 1200, and there you may use the same Raspberry Pis, but also you can use Raspberry Pi 4. And with the small adapter board, which is shown there on the picture down, you may also use CM4. which in my opinion is the best one, because there you have a lot of place for the cooling, because it's at the position in the Amiga where you have a lot of place for heatsink, actively cooled, passively cooled, whatever you would like. Yeah, but MO68 is running modern software, but we have also a lot of troubles. I mean, quite plenty of old Amiga games or demos were using features of Motorola CPU which are not so nice to emulate or not so nice to recreate. A lot of demos, a lot of code was using self-modifying code, and this self-modifying code was not only let's modify something, I don't know, 20 bytes far away from us. For example, state of the art is modifying the one instruction is modifying directly the subsequent instruction, which is pretty hard if you have previously translated the code and you try to execute the code which is modifying M68 code, and you have somehow to detect it. And also, in many times, MU68 with PyStorm is too slow or too fast. And it's hard to make one version which is working with everything you would like. But on the other hand, the very nice thing about which we have is most of the parameters of MU68 can be configured and changed on the runtime, which means, for example, we have a small EMU control tool which you can download and use on your PyStorm device, where you can adjust the instruction depth, which means amount of instructions which are translated in advance, inlining range, number of loops which will be unrolled, the scan depth of the CCR calculation, and so on. So with recent versions of MU68, we are able to run the most modern games or demos for the Amiga, and on the other hand, if you come to our stand, I can show you how the state-of-the-art demo is working, which was pretty hard to make it really running properly. But right now it's working. Okay, so some numbers from MU68. I have two which are just number crunchings. This is the OGRNG and RC572, which are just performing at about 2 million keys per second. I don't have numbers from other Amiga or Motorola processors, but we are really far away from that. For example, Quake 2 is working at least 30 FPS at the pretty high resolution. The memory speed in the fast region, which is the Raspberry Pi RAM, is in the range of 4 gigabytes per second, which was, I would say, never before like that on the Amiga. Chip memory is still relatively slow. This is due to the interface which we are having, but we are working on improving on that. The memory reading from the chip memory is pretty slow. On the other hand, the memory writing to the chip memory is at the maximum, because about 7 megabytes per second is the maximal amount on the Amiga 1200, for example. And in case of the sysinfo, which I don't like as a benchmark, but many people are using that for comparison, we have more or less 1 MIPS per megahertz. In this case, megahertz from the Raspberry Pi, which means if we are running Raspberry Pi CM4 at 1.8 gigahertz, we have 1,800 MIPS. Yeah, that's quite a lot, I would say. Okay, so let me show you how it looks like. This is a small test where the Quake demo is running at a pretty low resolution. It was just finding out if it's fast enough or not. Please note that in this case, there is no acceleration in the video driver. I mean, this is the pure CPU. The all 3D computations are done by Motorola. There is no ARM code inside. There is no 3D inside. It's just MU68. Yeah, I don't know if it will start at high resolution also. Oh yeah, 640 times 480. It's still quite fast. I mean, you can play with that game. Yeah. So this is the most accurate benchmark software for Amiga. As you may see, the chip writing speed what you have seen just recently with this right pixel is relatively slow, but everything which is bound to the CPU is, I would say, quite fast. The largest bulk, which is not MU68, is Amiga 4000 with 040 CPU. Once again, writing to the chip memory is slow, but everything else is just, I would say, blazing fast. The FPU is also very fast, and this is where we are going, and this is what we are achieving. TG test is again writing to the chip memory, which is slow, comparable with other Amigas, the same with the line test, and so on. Okay, how fast is MU68 for other applications? You can watch this video on YouTube. I don't have it on this laptop at the moment. You can smoothly play 720p videos on your Amiga if you like, which is also very, very good. If the videos have lower resolution, you may play 2, 3, 5, whatever you like of them. And I don't know, it's hard to concentrate on many videos watching at the same time, but on the other hand, you can also still do something with your Amiga when you're watching videos. Okay, so Amiga and beyond. What we are working at the moment now, we are working on the improvements of the firmware in the FPGA for the faster read accesses and eventually on the new protocol of communication between Raspberry Pi and FPGA. For the hardware side, we are working on near zero latency RGB grabber using a camera interface of Raspberry. It would be for example, Amiga 1200, where the entire video from Amiga would be outputted through the HDMI. Because at the moment, if you use Amiga and you use HDMI driver for Raspberry or for MU68, you have to use either a monitor switch or 2 monitors. And also CM4 board for the classic PyStorm is in the work. On the software side, we are working on improving FPU support and compatibility. With compatibility, we are already pretty far away. One of the another part is video VPU acceleration, because at the moment, as I already said, it's using CPU only, and Raspberry has a few other processors which we could use for acceleration. Let me just show you how this works. This is a test work in progress. The video resolution for classic Amiga OS here is 2.5K. And I will at some point, let me press play. At some point I will open a quite large image with resolution of something like 8K, and will try to move the window with it and scroll it just to have a look, just to find out if the acceleration is working and how good it performs. Please note that in this case the color depth is 32 bits, because in case of PyStorm and MU68 it's the fastest one. So yeah, let me move the window. Yeah, as you may see, it's pretty fast. And if you scroll the image, which was huge in this case, you also see no problems in either direction, which means the acceleration is working, and when it's ready, it will be released for everyone. I would say fast enough is it already. Okay, so MU68 is at the moment at version 1.0 RC1. RC2 will be available within next few days, I guess. There is one problem which I have to overcome, and once ready, it will be open for everyone. Yeah, and there is also a very, very distant future. We are working on a small pet project, which is the PyStorm in mini ITX form. It would contain multiple FPGA chips, which would emulate then Amiga chipset, for example. And Amiga chips would be splitted into several FPGAs, because we don't want to have one huge FPGA which is awfully expensive and which emulates everything. We would split it into few smaller ones. But not even ETA estimation is available at the moment. I mean, it's a pet project, and when we're ready, then we're ready. Okay, before you ask about Raspberry Pi 5, which was released a few days ago, it's a pretty fast one, and I was astonished as I have seen it. It will be available in October. I mean, we have both me and Claude ordered ones already, and we will find out if it's usable for MU68 and PyStorm or not. The problem is the Southbridge RP1 processor, because it's connected to the main ARM processor with PCIe. And the problem is not the speed of this PCI interface, because PCI is awfully fast already, but it has a latency which is in the range of 1 microsecond. Before you start the transfer, it takes 1 microsecond until the transfer is done. Independent if you transfer only 1 byte or if you transfer 100 megabyte at once. And that's the problem, because in PyStorm and in MU68, if we want to read, for example, chip memory, we have to instruct FPGA read, for example, 4 bytes at address and so on. And then we have to read the result back. This would be, in worst case, two transactions on PCI bus. And if every of them has 1 microsecond latency, we have already lost. I mean, that would be 500 kilohertz reading rate, which would be, in best case, for maybe 1 megabyte per second chip memory transfer, which would be much worse than we have at the moment. So that's the problem, and we will have a look if it's possible or not. I'm hoping that if the Raspberry Foundation will release CM5, they will not include this RP1 processor and will allow us to use it just as it is before, until now. Okay, at the end, I would like to ask everyone supporting me or supporting us. This is the list of people which were in the past and at the moment supporting me on Patreon. And yeah, if you like our work, the accelerator and everything we did is open source. You may use it, you may like it, you may build it, you may copy it, distribute it, sell it if you like, or just be happy with that. We will be happy that you're happy with the software, and yeah, if you like to support us, very well, we love it. If you just love using it, we love it too. I mean, it's awesome to have a big community of people who are using MU68, who are using PyStorm, and we are already very happy with that. And with these words, thank you for your attention. And if there are any questions, don't hesitate to ask now or come to us. We are down there, and talk with us. Thank you.